We have Jaymeeth Vasava, and this is his sixth use case, I believe, and he has done seven presentation. This is his seventh presentation. This is on the event recommendation system. So Jaymeeth is grown from what you call uh, 0 to 60 miles per hour now, or 0 to 100 kilometers, you can say. So I'll let him handle. So Jaymeet, go ahead and make your presentation on the ML study circle, ML system design under the study circle. And this is event recommendation system. Go ahead. Thank you.
So thanks a lot, Prakash, sir, for the introduction. Hello, everyone. My name is Jaymeeth Vasava, and I will be presenting different use cases on AI ML study circle. So this time's use case is event recommendation system. So when we say event recommendation system, we are thinking of when the user opens the website, let's say Eventbrite or Book My Show or something. So what kind of events are going to be recommended to the user? So and based on the user's past history and stuff, what kind of recommendations will be done? So that's what we are talking about, and that's what we'll be discussing here in this presentation. So let's get started. So when we talk about this, the first thing is that we will be assuming certain stuff, and we will be also having the discussion being taken in under some constraints. So let's start first with clarifying the requirements, what we want to build, and how the statements will be converted into ML tasks. So and the So we have to build a personalized event recommendation system to users. The business objective BO is to increase the ticket sales of an event management system and event management and ticketing platform. So only event is considered, and that is it is announced, event takes place, and event is finished, meaning event has expired. So no other interactions after the event has expired is going to take place. So it's a very short span of time compared to other stuff. So we have description of the event, price of the event, location, date, time, etc. The assumptions and the constraints that I talk about were, we don't have a labeled data set, so we will use user interaction data to construct a data set to train the model. So users have allowed to share their location to us. So we have a user location. User can become a peer-to-peer, can have peer-to-peer connection or become friends or have connections with different users. We can Users can also invite other users to the events. Uh, and there are both free and paid events both, and we are assuming that we have 1 million events happening per month and 1 million users across the website or application. For having the location information of the users, we can use third-party services such as APIs from Google Maps or map services to calculate the travel time and stuff. So as you remember, the business objective was to increase the ticket sales. So the ML objective is to increase the number of registrations from the users. So here the input to the model becomes a user or a user profile, and a user profile will be consisting of the past interaction of the user with the platform. And the output is the top k ranked rank the output is the rank list of top k events that are relevant to the user. So for this, what kind of categories can we discuss, and what are the different categories we should be going for? So different ways to solve a recommendation problem is to recommend popular events, which is a simple solution. Embedding based models which rely on content based filtering or collaborative filtering, and uh, re- so we have recommendation problems, which are first is rule based problem. Rule based is one category to it. The embedding based being another category to it. And but here we'll be more focusing on learning to rank algorithms. So get moving further with learning to rank algorithms, we have pointwise, pairwise, and listwise. So learning to rank algorithms are used for optimal ordering of items given the query. So having a query, what is the optimal ordering of the list from most relevant item to the least relevant item of the list. So going through pointwise, pairwise, and listwise, we have first pointwise. In this approach, we go over each item and predict the relevance between the query and the item using classification or regression methods. In pairwise, we the model takes two items and predicts which item is more relevant to the query. And in listwise, we the we predict the optimal ordering of the entire list of items given the query. So, for simplicity, we'll be using the pointwise approach here, as pairwise and listwise both have uh, both do have accurate results, but they are hard to implement and train. So, for this, we will be using binary classification model, which takes a single event and predicts if the user will register for it or not. So, one of the reason to use a binary classification is because either user will be going for it or not going for it. So in data preparation, the data engineering, the what kind of data that we have in hand. So the data available to us is user data, event data, friendship or connections, and interactions of user with the platform or the events. So for user data is the normal data that most of the social media platforms gather for the user. The event the event data, the various information about the event. You can also see the description about the event and in what category the event lies and price and stuff. For friendship is the interaction between the two fellow users of the platform and when the connection or the friendship was formed. In the interaction data, we have a user ID, event ID, interaction type, and interaction value. So if the interaction value, you can see that user 4 has the interaction type first of impression, then user 4 registers for the event and also invites user 9. So this is the kind of this is one example of interaction data and the timestamp of when the actions happen and the location. So, moving further with feature engineering. So feature engineering is going to play a vital role here as we are discussing about the event recommendation system. So, there is not much data about the user and the event interaction that we have. And so for that, we have to make new features in order to solve different problems. So, let's go through the points first. So, event-based recommendations are different from movies or book. So they are short-lived as there is less time from event creation and when it finishes. So there is no historical data, and because there is no historical data, we this faces a cold start problem and a constant new item problem because new data is also being coming due to different interactions and changing taste of users. So to solve these issues, we will be creating as many useful features as possible. So features created will be following of the following categories: location related features, social related features, time related features, user related features, event related features. So in practice, features can be much higher than this, not just limited to these five, but for this discussion, we'll be discussing this only. So starting with location-related features. So how accessible is the event? So accessibility of an event is an important factor to consider because if the event is happening somewhere in a remote or a hilly place, which is far from basic amenities or a public transportation or any kind of transportation, then and there is a chance that users uh, might not register themselves for such an event. So this might discourage the users from registering for the event. So the accessibility of the event is an important factor. So for addressing this, we can consider a feature called walk score, which is how walkable the event is based on the distance of the nearby amenities. So walk score will be calculated from 0 to 100, and will be bucketized into five categories, and how and which what those five categories you can see in the description. From starting from 1 through 5, 1 is a no car needed to 5 minutes requires a car. So similar to walk score, we can uh, also have a transit score and a transit score similarity, and bike score similarity, car and car score similarity, etc. So basically, these will tell us that how much a user is ready to travel for attending an event, and for that we can suggest or recommend those events to the user, which is in the which lies in the average category of what user has traveled in the past for attending the event. So next question is the event in the same country and city as the user? So this is also a different another question that sometimes user wants to travel to different places in order to attend an event, and or sometimes users are more comfortable to attend an event which are in close to the locality, or in the same city and stuff. So a very important factor for a user is whether the event is located in the same country and city as they are located. So we can create two features here. So if the user's country is same as event's country, then the feature is one, otherwise zero. If the user city is same as event city, then the feature is one, otherwise zero. So so the different the moving further with the different question is the user comfortable with the distance? So some users prefer shorter distance for the event, while some prefer that are farther away. So we use following features to capture this, which is the distance between the user's location and the event's location. This value can be obtained from APIs and can be bucketized into categories. So you can see the different category and what it represents, starting from 0, which is less than a kilometer, through 5, which is more than 100 kilometers. So for this, we have distance similarity as a before it was discussed the walk score and walk through similarity. So the distance similarity is how much is simply how much the user will be able to, or is willing uh, to cover the distance in order to attend the event. So, in the diagram, you can see that there are different aspect of it being displayed that we discussed just now. So we have accessibility being covered. We have uh, geographical aspect, which is same city or not, same country or not, which is one which means that it is in the same city and the country, and the distance that the user is ready to travel, and it's information. So all of this is merged together in the concatenated features. So in data preparation, moving further with time-related features. So how convenient is the time until an event? So sometimes a user likes to wait until to register themselves for an event, and they do not register right. Or maybe sometimes a user would like to register right when the event has been created, or would like to wait until the last moment when they can be able to register. So this is what it captures. So in order to capture this information, we can create different categories and fill in the information that we want for different users. So, so remaining time similarity is a difference between the remaining time and the average remaining time of events previously registered by the user. The estimated time travel from the user's location to the event's location, which can be collected from the Google API or Google Map API or other map services, and bucketized into categories. As you can see, from 0 through 8, we have it. And the estimated travel time similarity, the difference between the estimated travel time to the event in question, the average estimated travel time of events previously registered by the user. So are the date and time convenient for the user? So sometimes a user would like to register for the event on weekends, or sometimes the users like to have it on weekdays. So so for capturing this information, we can create a vector of size 7, and 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 each value counts the number of events the user has attended on a particular day. So that's what's happening in the diagram below, that we have a user's information, and the user has been actively participating in events on Fridays, Saturdays, and Sundays, and but the user has never attended an event on Mondays and Wednesdays. So trying to recommend an event to the user, to a user with such a history, we it is not feasible to have the events being recommended on Mondays or Wednesdays high up in the list compared to, so we can suggest such users to have events which are more on Fridays, Saturdays, and Sundays, or weekends. So for capturing this information, the users can also have more time related preferences for their for attending the event. So for capturing this, we can also use per hour user profiles, and similarly, we can also add day and hour similarity to it. So this is what the whole time related features look like. So we have a remaining time to the event, estimated travel time to the when the where the event is going to take place, remaining time similarity, estimated time travel time similarity. Sorry. So hour similarity and day similarity. So all of these are going to being merged in the concatenated features further. We have a social related features. So how many people are going to attend? So in general, users are more likely to attend an event if there are a lot of other attendees. So we extract the following feature to capture this. So number of registered users for this event, the ratio of number of total registered users to the number of impressions, a registered user similarity, the difference between the number of registered users to the for the event in question and previously registered events. Further, the features related to attendance by friends. So users are more likely to attend for an event if their friends are attending it. So number of users friends who are attending this event, ratio of number of users, number of registered friends to the total number of friends, and registered friends similarity, which is a difference between the number of registered friends for the event in question and previously registered events with friends. So, discussing further with the social related features, so a user can be invited by the friends or other fellow users of the platform. So, and so we can also have a connection of a user with the host. So because we like to attend events that are hosted by one of our friends, then that can be a connection that can be made and a feature. So if in that case, if the host is a friend to the user, then we can have the value of 1 to capture it, and 0 otherwise. So how often has the user attended previous events created by this host? So some users are interested in following particular host event. It can be also due to some of the genres that the user has followed, and the host is particularly focused on hosting events of that genre and stuff. So user-related features, the age and gender. So some events are geared towards a specific gender and age. For example, woman in tech is more age. Woman in tech is more uh, gender focused event, and life lesson for to excel in your 30s is more age focused event. So two features to capture this information is user's gender encoded with one hot encoding, and user's age bucketized into multiple categories and encoded with one hot encoding. So, so now moving further with the event related features, which is a price of an event and the description of the event, as we have already covered the location aspect of it, so we won't be considering the event's location here. So the price of the event is also a deciding factor whether the user is willing to register for the event or not. And the price similarity is how much price is on average is a user willing to pay. A particular user is willing to pay for the particular event. So So another another question is how similar is the events description to the previously registered events description? So to capture this, we can use the term frequency inverse document frequency in order to have uh, the information of the descriptive information of the event being captured. And to do this, we have to test what is the impact of term frequency inverse document frequency. So we can use with and without it in order to evaluate the performance of the model with term frequency and inverse document frequency. So this is the whole what the features look like. We have user features, the event features, and the social features. The user features, the age being bucketized and one hot encoded, same for gender. And then we have event features of price similarity, event description similarity. Then we have social features of users, the users connection with other users being friends, and also the connection of a user with the host of the event. So, so in addition to this, there can be more other features which are host popularity, which can be leveraged in for more registrations more registrations for the event. The user's history can be another thing that can be used in order to recommend uh, more relevant events to the user. The events category, auto-generated event tags, etc. Auto-generated event tags can have the chance of being noisy, but still it can help us in order to categorize the events in order to give the recommendations. So the additional points to it are a batch, which is a static, and a stream, which is a dynamic features. So batch are the batch features are the features which are less which changes less frequently, which are age and gender is more static. Similarly, we have a streaming features which are more which considers like a number of users registered or a time remaining until just a second. So feature so with the batch is being static features which are gender and age, and streaming features are are the one which which are constantly with the will be representing the real-time data, which can be time remaining until event or the number of users who have registered for the event and stuff. So feature computation efficiency is which means computing features in real time. So for this we uh, for computing features such as location of the user and the event, we can rather use separate features for it and let the model implicitly compute the information of those two locations. So using a decay factor is basically how long data is relevant. So how long a user's action can be referred to for its optimal use and user's habits as a user's habit changes with time. So so that is using users' last X interactions, and decay factor gives us more weighted to users' more recent interactions and behaviors. Moving further with using embedding learning to convert the user and an event into embedding vectors and used for representing them. Then we have creating features from users attributes will create or may create bias. So using age and gender for finding a candidate a good match for a job can lead to discrimination. So that is the reason to be wary of users features that can introduce bias. So moving further with model development, we have as we are using binary classification models, we'll be discussing few of them. So starting with logistic regression, the models which models the probability of a binary outcome by using a linear combination of one or more features. So the advantages of binary classification are fast inference time. Uh, Fast inference time as there are just a second. So it has fast inference time because it has a weighted combination of input features. Computing weighted combination of input features is fast. We have efficient training because given the simple architecture, it's easy to implement, interpret, and train quickly. And it works well with the data is linearly separable, as you can see in the diagram on the right. And it is also easy to interpret and easy to understand because the weight assigned to each feature indicates the importance of different features, which gives us insight into why a decision was made. So the disadvantages to it are non-linear problems cannot be solved since it uses a linear combination of input features, and there is also a problem of multicollinearity, which occurs when two or more features are highly correlated. And also multicollinearity occurs when independent features in a regression model are correlated. This correlation is a problem because independent variables should be independent. And if the degree of correlation between variables is high enough, it can cause problems when you fit the model and interpret the results. Moving further with decision trees. So in the first diagram, we have a decision tree. The plus are the inputs that can be considered as positive, and minus meaning negative for the output that it gives. So the advantages to a decision tree are is fast training because they are quick to train. The fast inference time because makes predictions quickly, and little to no data preparation because it does not need more data normalization and stuff. And it is easy to interpret the outcome and how the decision tree has reached that outcome. The The disadvantages to it are non-optimal decision boundary, which produce. So decision tree models produce decision boundaries that are parallel to the axis in the feature space. So this may not be the optimal way to find a decision boundary for certain data distributions. And then we also have a problem of overfitting. So decision trees are very sensitive to small variations in data, and uh, and a small change in the input may lead to different outcomes, and also a small change in data can also uh, change the structure of the tree. So for so in practice, naive decision trees are rarely used, because they are too sensitive to change in data. And two common techniques to reduce the sensitivity to decision trees are bootstrap aggregating, bagging, or and boosting. So we'll start with bagging first. So different models are arranged in parallel manner, and the inputs are given to a subset of the same training data set is taken, and those subsets are given as are given as a data to those those models, and the combination of those outcomes is taken, and with the help of voting or averaging, the output is finalized from all the models. So the advantages of bagging is to it reduces the effect of overfitting. It does not affect the training time much, as the models are parallelly trained, and because the models being trained in parallel, it can process input in parallel, hence less latency added at the inference time. But bagging still faces the problem of reducing the efficiency of training, and there different weak learners are used in boosting in sequential manner. So by meaning of weak learner, we mean that these are simple decision trees that are used, and uh, those with the combination of these simple trees or weak learners in a sequential manner, each of the decision tree will be keep on correcting the output given by them in as we move forward. And that's what's happening in the diagram below, that the input features are given to the decision tree, and while correcting with each of the decision tree being correcting the output of the previous one, and overall developing the whole giving us a good output. So the advantages to decision tree is boosting reduces bias, and the advantages to boosting is boosting reduces bias and variance, which combining weak learners leads to a strong model which is less sensitive to the change in data. And the disadvantage to it is slower training and inference time. So given the classifiers are trained based on the mistakes of the previous classifiers, they work sequentially. This adds to the serving time due to the sequential nature of boosting. So boosting is preferred more as it reduces bias and variance both. So some of the boosting based decision trees are XGBoost or extreme gradient boosting, AdaBoost or adaptive boosting, and gradient boost, which are commonly used for training classification models. So third is a gradient boosted decision tree. So it's one of the commonly used tree-based model utilizing gradient boost to improve decision trees. So variants of gradient boost decision tree is XGBoost, which is extreme gradient boosting, which has also demonstrated strong performance. So pros to it are easy data preparation. So similar to decision trees, it does not require data preparations. Reduces the variance as a gradient boosted decision tree reduces variance as it uses the boosting technique and reduces bias. Uh, the prediction error by it reduces the prediction error by leveraging the several weak classifiers and iteratively improving upon misclassified data points from the previous classifiers. And it works well with the structured data, works well within the structured data, which is also a disadvantage if you are working with non-structured data or unstructured data such as image video, audio, etc. So other disadvantage to it are lots of parameters to tune, which is a number of iterations, tree depth, regularization parameters. So regularization uh, is used to fix overfitting in the ML models. So regularization parameter reduces overfitting, which reduces the variance of your estimated regression parameters. But it does that at the expense of adding a bias. So, and also technically speaking, regularization avoids overfitting by adding a penalty to the model's loss function. So moving further, so just a second. Sorry. So it is so gradient boosted decision tree is also unsuitable for continual learning from streaming data, meaning in real time data. So continuing with the unsuitability for the continual learning. Uh, in the event recommendation system, the model has to continuously learn about new data and new changing behaviors of user. So this is not possible without continuous learning, and we need to train gradient boosted decision tree from scratch regularly, which is very expensive. So, and it is vital for a good recommendation system to adapt itself to new data continuously, and to be able to adapt to new data, we have to fine tune a model. For addressing those issues, of having a cold start problem or addressing the issue of new item problem, uh, a new data problem. We'll be discussing the neural networks next. So all of those uh, all of those issues that we have previously mentioned about is faced or is addressed by the is addressed by the neural networks. So all of the complexities is addressed, and it can also learn the nonlinear data structure. So so the advantages to a neural network is continual learning, the which works well with unstructured data, and expressiveness, which means that we can have more we can use a higher number of learning parameters in order to learn a more complex task and more non-linear decision boundaries and have more non-linear decision boundaries. The disadvantages are it is computationally expensive to train. The quality of input strongly influences the outcome, as neural networks um, are sensitive to the input data. So that is the reason the input data will influence strongly on the outcome of it. The large training data uh, is required in order to train a neural network, and it's a black box in nature, meaning that it is not easy to understand which features are influencing on the outcomes, as input features go through multiple layers of outcome. So, so which model to use? So we can start with gradient boosted decision trees variant XGBoost, which is fast to implement and train. The result can serve as an initial baseline, and once we have a baseline, we can shift to building models with neural networks. So we have a massive training data set is available due to the user interaction inviting friends, new events being as a new events also being registered. And given the number of users, it creates a big data set. And neural networks can work with non-linear data also. So and they are good with complex tasks and taking many parameters. So model training is for model training, we have to construct the data set. So for constructing the data set, we have extracted the user event pair from the user interaction data. If the user has attended the event, and then it is marked as one and zero otherwise. So what? But there is an issue with that, which is uh, which is whenever a user is going to register for an event, and the user normally scrolls through many events, sometimes hundreds of events in just in order to register for one event. So that is the reason it can be a very noisy data. So and it being noise making it noisy, it also creates an imbalanced data. So in order to solve this imbalanced data set, we can use focal loss or a class balance loss in order to train the classifier or undersample the majority class. Now, choosing the loss function, we will use a binary cross interval to optimize the neural network. Yeah. Evaluation for the evaluation for evaluating the model and how it performs. So first there are recall at k and precision at k, which which are good metrics, but which are of not use to us because it does not consider the ranking quality of it. Next, we have is a mean reciprocal rank, which only considers the first relevant event or item that it comes in the list, but it ignores the other past relevant or irrelevant events that might come in the list. So that is the reason we can't use MRR. NDCG is used when we have a non-binary similarity score with the user and the event. So that is the reason we'll be using the MAP, because MAP is designed for MAP, which is a mean average precision, which is designed for binary relevance only. And we have to see whether the user is registering for the event or not. So and so these are the offline metrics. And the moving to online metrics, we have so the business objective is to increase the revenue of the ticket sales on the platform. So in order to, so so the online metrics which can capture this as well as show us different engagements are click-through rate, but the which is number of number of clicks and divided by number of impressions. But relying on click-through rate is insufficient, as it also considers the clickbait events and that might be on the platform. And next, for addressing that issue, we use the conversion rate as well. So conversion rate is total conversions divided by the total visitors. So a high conversion rate indicates the user is registering for the recommended events more often. Next, we have is a bookmark rate, which is so how often users bookmark recommended events, given that the feature is present on the platform. Next is a revenue lift, the increase in the revenue due to the event recommendations. So this is the whole overview might look like. So we have online learning pipeline and online prediction pipeline. So online learning pipeline is going to address the issue of a cold start as well as the new data problem that the new item problem that we are facing. So it trains the model and evaluates the model and deploys the model. So that's what the online learning pipeline is responsible for. So and we have other is a prediction pipeline. So prediction pipeline will be giving us the users, taking the users input and using using event filtering. We can have the candidate events generated for us, re-ranking services while interacting with the feature computation, which will have the feature store and raw data. So feature store is the static features like age and gender, and the dynamic features are in the raw data, which are real-time features, which are time remaining for the event and how many users have registered for the event. And based on those feature computations, the ranking services will be sorting the list of events for the user. So so online learning so online learning pipeline, because the event recommendation system are a cold start and faces a constant new item problem, so consequently continuously fine tune to adapt new data. So online learning pipeline is responsible for training new models by incorporating new data, evaluating training models and deploying them. Prediction, and then we have prediction pipeline, which is responsible for recommending top k most relevant events to a given user. So we also have a event filtering for prediction pipeline. So which helps us to narrow down from millions of results to a small subset of events. So we can have in event filtering, the other thing is that the user can also use its own filters in order to narrow down the results from a big number to a small number, which is, let's say a user used a filter called concerts for the events. So from all the events that are taking place on the registered on the platform, the user has already narrowed down to concerts. So only concerts will be used, and the candidate generation or the candidate generation for the events will be made. So ranking services, as also mentioned before, it works with sorting down uh, the relevant items according to the user. So that's what's happening. The user's whole profile and the candidate events are taken as an input by the ranking services, interacts with the feature computation, which has the static features and the dynamic features, and using those, the ranking services sorts the list of events for the user. So, and that was the whole system for the event recommendation system. So let's quickly summarize it. So first, we started with clarifying the requirements, where we discussed about different assumptions as well as the constraints within which we are trying to discuss this whole event recommendation system, where we discussed about the BO or business objective, which was to increase the ticket sales by increasing the registration for the events. So we translated the business objective into ML task, which was increasing the ticket sales, means increasing the user registrations for the event. For specifying the input and output, the whole user profile was the input, and output was the list of events according to the profile of the user. The ML category we discussed was rule-based, embedding-based, and learning to rank algorithms, where we went with learning to rank algorithms and discussed the point-wise, pair-wise, and list-wise, and we went with point-wise for its simplicity and easy to train. For data preparation, we discussed about the data engineering or the data that we have in hand, which was user data, event data, friendship data, interactions between user and the event. Then feature engineering, we made a lot of features because we didn't have an annotated data set. So that's why we engineered many features and many different features based on the user event interaction data. So uh, five of them were location related features, time related features, social related features, user related features, and event related features. And also to do it was to address the fact that we were facing a cold start problem for the event event recommendation system, and also new data problem in order to adapt to changing behaviors of the users. For model development, dis- uh, we discussed about logistic regression, decision tree, bagging and boosting in decision tree for addressing the issue of overfitting, then gradient boosted decision tree, and discussed about the neural networks. And then we constructed the data set from uh, user event pairs for training the model. Then for evaluation, we used for offline evaluation, we used mean average precision as it is used for binary relevance. And for online metrics, we uh, used click-through rate, conversion rate, bookmark rate if the platform allows it, and revenue lift. Serving while serving while having the overview of the whole system, we we talked on the online prediction pipeline, which was to address the issue of a cold start problem. And uh, co- just cold start problem as well as the new data problem. And also we discussed about the prediction pipeline, which was so learning pipeline was also responsible for apart from those two issues, was also responsible for evaluating the models and deploying them. So the deployed models then were used in real time by the users, and the prediction pipeline was the place where the deployed models were kept. So for a prediction pipeline, we discussed about event filtering and ranking services. For event filtering, for narrowing down from millions of events that are happening on the platform to a small subset of them, and ranking services uh, for creating a rank list of sorted relevance to the user. So even though we have discussed this system with lots of assumptions and constraints, and there can be different other improvements that can still be talked about regarding this event. So additional improvements to the system can be different types of biases that may be present in the system, which can be addressed. The feature crossing to achieve more expressiveness, and how do we ensure the diversity who wants to have a diverse recommendations in the on the by the platform. So there can be some users who can be focused on single domain for the event recommendation, but there can be different users who wants to have a who expects diverse recommendations to them, but also not having completely irrelevant recommendations to them. So how can we ensure to those users to have a diversity or have a relevant diversity to them? So another one is event management platform is a two-sided marketplace, meaning both host and users are both engaging in the activity. So we need to ensure if it is optimized for both the sides, the host and the users, and how to keep the platform fair for different hosts. So let's say if a host is of a particular niche, how can we be fair to it and have have the host in or treat the host in same fairness to how the other uh, host or their events are being recommended to different users. So the last one is how to determine a right frequency to update the models. So as we have already talked about the online learning pipeline, which was responsible for addressing different issues that we are facing. So how can we find the right frequency for updating the models with new data changes and changing behaviors of the user? So that was it for the event recommendation system from my side. Thank you.
Jimit, one question would normally come here. I think uh, the one first thing is excellent presentation. We liked it, and it has a lot of details, including what choices you made and how you made. One thing is, if this is offsite, then I can understand the parameters. What happens if it is on-site? That is, it's online, let's say, not on-site, but online or hybrid. How do you answer
Okay,
that?
so the main discussion was only relating to the on-site events like concert and stuff. For let's say online event or let's say hybrid event, there can be different parameters that can be introduced more, or there can be different. So let's say it's a completely online event. So for that we can remove the location based parameters because a user is free to watch or attend the event from anywhere. So those are the kind of adjustments that will take place in that case.
Excellent. So let us ask other people, Jaymeeth, Ritish, Ritish and Nikhil and Ansh. Uh, so, do you have any questions you can ask? Because I also
Or
discussed.
suggestions or anything.
Yeah, go ahead. Let's start with Ritish. Go ahead. Do you have any questions? I can unmute you if you are. Yeah, go ahead. No, you're not. Okay. Let's go with Nikhil. Nikhil, you have anything? No, looks like.
No questions from me.
Uh, okay, Ritish will unmute mic later. Okay, no problem. And what about Ansh? You have any questions? And are you regular? You joined recently. Maybe you can comment on yourself, how you came across, etc. Are you there, Ansh? You have any questions? Okay. Looks like we have not many questions. So let me ask you one more on the meantime. If anybody comes, let's see if they want to ask. One of the thing I was finding interesting is that it's quite a bit of dynamic data in the events because events are very fast moving. If the event is fast moving and data is dynamic, uh, is it better to do with because you got data which is textual also, right? As well as you can use image data. So when you have a platform, when you have on-site data, most of the texting is easier to follow, right?
Yes.
So what would why the neural network?
So neural network is because it first it needs a large data. So it addresses the changing dynamics of the incoming data, and also there is so also there is a problem that the events are very short in span. So let's say there is a 2 week prior to it. an event has been announced, and once the event has taken place after 2 weeks, it has expired. So there is not much data that is present for the user and for the platform to collect from the users. So in order to address that, neural networks are used, in but neural networks themselves need more or a large data set to train themselves. So for that, we first used the extreme gradient boost or XG boost in until it makes a baseline for us to start or shift to the neural networks.
Fantastic. So baseline you draw with the text.
Yeah, extreme gradient boost first, and then shift to neural networks for a more accurate and
Okay. So you have
uh,
a combination of
performance.
models combined. You combine the
Yes,
models.
in a way, when shifting is happening, it can be combined thing, but later on shifting to neural networks, that can also be done.
So historical data is important. Otherwise, you have to do cold start for new user and all that.
Yes,
New user, there is no data available, so you have to track them and get some data, and it
yes,
may be useful in the next event. But recommendation in next event will be better than the start one. So in the
yeah,
start, you have to just identify based on the dynamic data what is happening.
yes,
Makes sense. Okay, and this is based on event recommendation like bright. What is it? Event bright. So
yes.
what do you say about geo event? Can you compare the two? Have you used geo event?
Yes, we have used GeoEvent for EOT of TechFest 2024.
Yes.
So it was
Okay.
a so
Good.
so I think comparing, we can compare one aspect of Eventbrite with GeoEvent is that it can be done. Both can have online events, whereas Eventbrite takes into consideration of all kind of events on site and hybrid and stuff. Uh, for a geo event is more, I guess, online friendly rather than that, because it has it gives you the tool uh, the, to coordinate with different hosts wherever they are. So
Course.
yeah, and that's a good thing for them. They are still uh, they have still a lot to develop, but they are doing good, I guess.
Yeah. So basically, the volume of people in India is so high
Yeah,
that you get lot of attendees. So it's
yeah,
a variation, and plus audio, of course, is the key, right?
yeah,
Sometimes the audios of the client side you cannot control.
yeah,
So that is one challenge. Yeah. So there are plus and minus, but they are improving a lot.
yeah.
I think they are comparable. Actually, they are comparable.
Yes.
Cost-wise, they are definitely much better than the even brights types. So, of
Hmm.
course, cost comparison knocks them out. They generally on the cost comparison, Indian like HOVA or something is there in the US for
Okay.
event management and all. So those are expensive. Whereas Geo events is a much cheaper. Uh, they can be done for a whole year in less than what you call 50, 60,000. So they are definitely much, and you can do as many events you want. For an event, on average, around it takes 5,000 rupees, whereas which is on a big scale, I'm putting. So if
Hmm.
5,000 or 4,000 rupees. So even if you get 5 or 6 paid uh, viewers of 500 rupees, you can recover the whole thing. So GL
Hmm.
event is definitely much economical compared to all these bigger ones like um, Bright, even Bright, and there are many. Many. So anybody, any question? Ritesh, Nikhil, and anything, or shall we close down? We are waiting for your inputs. If you have any questions, I will. Uh, maybe I can do one thing. I can stop recording now, so that we can talk uh, informally. I'll stop the recording.